Let's review. The Nernst equation allows us to calculate a cell potential whenever some of the conditions of the cell are non-standard. And there's the Nernst equation. E is equal to E naught minus RT over NF log Q. E naught is the standard cell potential in volts, V. R is equal to 8.314 joules per mole Kelvin. T is the temperature in kelvins. N is the number of moles of electrons transferred. F is Faraday's constant, which is 96,485 joules per volt per mole of electrons. And Q is the reaction quotient, products over reactants. Here we have an equation, and we're asked to find the cell potential at 55 degrees Celsius when the cadmium ion concentration is 2 molar and the iron 2 ion concentration is 0.03 molar. Let's notice a couple of things. Firstly, we have a non-standard temperature. 25 degrees Celsius is standard temperature. Furthermore, we have non-standard concentrations. Standard concentrations would be 1 molar. If either one of these came up, we know we would have to use Nernst. Since both of them come up, yes, Nernst is the way to go here. We're going to look up a couple of equations from the standard reduction potentials table. The reduction of iron 2 ion and the reduction of the cadmium ion. We're just going to copy those numbers from the table. What do we do with all of this? If we look at the equation at the top of the screen, we notice that the cadmium is running as a reduction, whereas the iron is running as an oxidation. In other words, this equation in the real situation is running backwards, which means we're going to need to change the sign on the standard potential for that equation. The iron is going to be the anode, that's where oxidation is happening, and the cadmium is going to be the cathode. E naught, the standard cell potential, is going to be not negative 0.44 volts, but rather positive 0.44 volts, and then we need to subtract off the 0.40 volts from the cadmium. This gives us a rather small standard potential, 0.04 volts. Now, let's go to Nernst. What do we have for these other values? We know the value for R. We can very easily calculate the Kelvin temperature. What would N be? N is the number of moles of electrons transferred. If we look at the equation at the top of the screen, hopefully we don't have too much trouble convincing ourselves that N is going to equal 2 here. F is Faraday's constant. And what about Q? Q is the reaction quotient, products over reactants. Products, the concentration, is going to be right there, 0.03 divided by reactant concentration, which is 2 molar. The Nernst equation is going to be fleshed out like that. And now it's simply a matter of typing that into our calculator. If you know your properties of logarithms, you will note that the logarithm of this number will be negative. And that negative, coupled with this negative sign here, will give a net positive change, which means our cell potential will be larger than the standard cell potential of 0.04 volts. That is a thermodynamically favorable process, having a positive cell potential.